DC motors produce high torques for short period of time. Why for short period of time? Because the DC motors depend of the batteries. Depending on the capacity of the battery in amps per hour, you can drain more or less amps for more or less time. When the current is passing through the wire, when the current is moving through the conductor, the current is moving in this direction. This is your right hand. The current is moving in this direction, and the magnetic field, the field is around the wire. The magnets are divided in two types of magnets. Permanent magnets is a hard steel, hard ferrous alloy that when you power the coil, keep the separation of the charge permanent. The electromagnets are fabricated in a soft iron, like a cast iron, and the magnetic properties stay only when the coil is powered. When you remove the power on the coil, the magnetic properties disappear. What happens if I put a rotor? What happens if I have a rotor like this? No with two terminals, with more. Positive, negative, positive, negative, positive, negative. How can I power it? Those electromagnets? Oh, because I have the slip rims here. I connect the brushes, and the brushes bring the current from the ignition switch. What happens when the positive magnet is practically in front of the other one? You can touch? No, they repel. What happens if I have electromagnets in the rotor and permanent magnets on the stator? What happens in the moment that one positive is in front of other positive, or one negative in front of other negative? The rotor spin, and the other one spin, and start the motor. This is the procedure to reverse rotation in a small DC motor using a toggle switch, double input, double output. The procedure is like this. In the middle, in the input, you connect the positive and the negative of the battery. And in the output, this is the motor, this is the blower, the positive and the negative, and you cross this position here and this position here. When I select the top position, the motor spins clockwise. When I select the bottom position, the motor works backward. This is a typical DC motor with a reversible rotation. If you check the motor have the negative in the middle and two positives. Depending if the positive current is entering here, the motor rotates clockwise. If the positive current is entering here, the motor rotates counterclock. Depending where is entering the positive, the motor rotates in one or other. Internally, it's because this motor have a double winding. The customer complained that the anchor is going down, but not up. The anchor is going down, but in the other position, nothing. Okay, you need verify. The first step is go where the motor is located and verify if the motor is in good condition. Doesn't matter if the solenoid control box or the switch is good, you need verify if the motor is in good condition. The proper way to do that is connect a big cable from the positive of the battery and goes directly into the right side and left side movement. Okay, this position is good, and now, okay, my motor is in good condition. This is the switch to operate those relays and work exactly the same like the solenoid control box. You replace that expensive equipment with $20 for this situation, and this is a permanent good solution. You can replace this for this forever. You don't have any problem, you don't have any inconvenience.